It is currently 21:20 Universal Coordinated Time on Friday, May 27th, 2016, and you are looking at a live Falcon 9 on the pad in Cape Canaveral, Florida. Good evening, and welcome to the SpaceX launch of Thaicom 8 to geostationary transfer orbit. My name is Brian, and I'm excited to be all the way back from the launch sites here at company headquarters in Hawthorne, California. Now, I'm currently just standing outside of Mission Control Center, where inside the glass beyond the viewing employees, operators are gearing up to enter the countdown. Now, today's launch will be occurring in about 20 minutes at 1740 Eastern Time, or about 2:40 p.m. here on the local Pacific coast. Today, we will be placing Thaicom 8, a communication satellite, into orbit such that it delivers coverage to parts of Thailand, India, and Africa. We'll talk more about the specific mission later, as well as provide some status updates on the vehicles and attempt to give you another live viewing of the landing. With an exciting program ahead of us, let's get started.
This is Tom Perderio. I'm a firmware engineer in the avionics department here at SpaceX. Now, it's looking like a beautiful day to launch a rocket at Cape Canaveral Air Force Base on the space coast of Florida. Now, Cape Canaveral Air Force Base actually has many launch pads, some for NASA, some for the Air Force, and some for other private launch contractors. But Space Launch Complex 40, which is what you see right here on your screen, is operated exclusively by SpaceX for the Falcon 9 rocket. We actually like to launch from Cape Canaveral because it's just about as low latitude as you can get in the contiguous United States, which allows us to utilize the full momentum of the Earth's rotation as we launch east out over the ocean. Now let's get a little familiar with the pad and what you're seeing on your screen. The big structure right in the middle is the Falcon 9 rocket. And we actually assemble the Falcon 9 rocket in a hangar that's just off the screen. We assemble it horizontally in what's called the transporter erector. That's that support structure that's currently standing right next to the rocket. So we assemble it horizontally on the transporter erector and then roll it out on big rails right to the launch pad and erect it vertically. And then just before liftoff, the transport erector actually leans back just a little bit to allow the rocket to clear the tower. Now, there are 4 more towers here. They are these lightning towers around the pad. These are essentially just big lightning rods so that when lightning strikes, and it happens very often in Florida, it doesn't damage the rocket or any other sensitive pad electronics. Now, the Falcon 9 is actually just a stack of tanks, really. It's made up of 3 different sections. The first stage takes up the bottom 60% of the rocket. Then on top of that is the second stage. And then finally, the payload fairing right at the very top. Inside those tanks are super cold liquid oxygen and compressed kerosene, or RP1 fuel. These really, really cold fluids are separated from the hot, humid Florida air by only a small, thin aluminum skin, which is why you can see some of that condensation smoke boiling off. That's totally normal, just locks boil off and condensation. It'll continue to happen right to the end of the launch. So just as soon as, so we'll be launching in just a few minutes here.
Hi, I'm Lauren Lyons, and I'm a mission integration engineer here at SpaceX. Today we're launching Thaicom 8, which is a 3,000 kilogram Thai communication satellite, and we're taking it to geostationary transfer orbit. Once the satellite reaches its final orbit, geostationary orbit, it will provide Southeast Asia, South Asia, and East Africa with broadcast and data services. This is actually SpaceX's second time launching a Thaicom satellite. The first was Thaicom 6 back in 2015. Today we're going to be continuing our experimental efforts to land the first stage of the Falcon 9 on our autonomous spaceport drone ship, in this case, of course, I Still Love You, off the coast of Florida. Like our last flight, which was JCSat-14 just a few weeks ago, this is also a geostationary transfer orbit mission, where the first stage is expected to see extreme velocities and re-entry heating on its way back to Earth, making this another challenging landing. But while sticking this landing is not entirely likely, as you saw with that last flight, it's also not impossible. That marked our 3rd successful landing and our first landing of a rocket that delivered a payload to geostationary transfer orbit, which means the stage is traveling much faster and it had far fewer remaining propellant in the tanks than the previous 2 low Earth orbit landings before it. After hitting the atmosphere at 6,300 kilometers per hour and experiencing 5 times the aerodynamic heating of the CRS-8 landing before it, the Merlin engines relit at only 850 meters above the Earth, touching down at 4 kilometers per hour at a mere 2 meters from the bull's eye at the center of the drone ship. And all that with only 3 seconds propellant remaining in the tank. While today's landing is expected to be similarly challenging, there's no guarantee that we're going to get the same result as last time. But we're still going to try our best to bring Falcon 9 home. Over the course of the webcast, we'll talk about what our plans are for that JCSat booster from the last one, the future of the other 2 Falcon 9 first stages of 39A, and we'll also tell you about this Thaicom satellite, its purpose, the trajectory is on, and follow that up with a little rocket science 101. So we've got a ton of really cool stuff planned today. Before we jump in, let's get an update on the status of the Falcon 9 right now.
Good afternoon, everybody. I'm John Federspiel, a lead mechanical design engineer here at SpaceX. And as you know, we are launching the Thaicom 8 satellite to a geostationary transfer orbit. Now, I've been following along with today's countdown, and the good news at this moment is all stations are go, and we are lurking no issues at the moment. As you know, yesterday we postponed our launch attempt out of an abundance of caution. Now, for every launch, we carry out extensive checks, and as part of these checks, we found that the motion of an actuator on our second stage engine, which is basically what we use to help steer the vehicle, was slightly off. This actuator is responsible for directly gimbaling the engine in flight, which allows us to adjust the vehicle's pitch and yaw through ascent. Now, while the behavior we saw yesterday was likely not a risk to a successful flight, it's always better to be safe than sorry, so our team took the extra time to address this issue. And since then, we have performed continuous checks across the Falcon vehicle, and we are currently working no issues at the moment. Looking full on our refined kerosene, RP1, full. And we're tracking nominal fill rates for our liquid oxygen, right now nearly full on stage 1 and continuing to fill up our stage 2 tanks at the moment. We're going to keep filling up that stage 2 tank right up until about the 2-minute mark, trying to make sure that the liquid oxygen is as cold as possible. Meanwhile, the Thaicom 8 satellite transitioned to internal power at the T-minus 40-minute mark. They're tracking no constraints at the moment for today's launch and are also good and ready to go. And the range has also been checking out their radar and tracking systems. They are also standing by and ready to support, tracking no issues at the moment. Speaking of the weather, though, that's kind of the last thing of the 4 main checks we look at. We are tracking a 20% chance of violating. The only thing that would potentially set back today's launch would be a cumulus cloud rule. Right now, everything continues to be go, though, for today's on-time launch at 2:40 p.m. Eastern Standard Time. And so to recap, both Falcon 9, Thaicom 8, the range and weather are go for today's launch.
As the audience starts to trickle in behind me, let's take a moment to discuss both the customer and the specific mission for today. So the customer is Thaicom, and the mission is Thaicom 8. These guys have been launching satellites all the way back since 1993 with Thaicom 1. Of the 7 that they've previously launched, 4 are still in active service out in space. The others have been decommissioned. So today will mark the 5th satellite that will be up there, providing coverage to specific surface regions of the Earth. Now, Thaicom 8 was built by Orbital ATK out in Virginia, and it follows the GeoStar bus. This is a bus with a lot of history, and Thaicom 8 for today's mission will actually be flying the next generation of that, the GeoStar 2 bus. So where will Thaicom 8 be going? SpaceX's second stage will take it all the way up to what we call Geostationary Transfer Orbit, or GTO. The spacecraft itself with onboard propellant will then send itself all the way back up to geostationary orbit, or GEO. Now, why are those both called geostationary? It's because the angular velocity of the satellite in its orbit is the same as the rotation rate of the Earth. So although both bodies are in motion, they're in motion together, and so you stay above the same continents on Earth. This is really important for communication satellites that want to focus their radios on a specific region. Now, in terms of technical specifications of today's Thaicom 8 satellite, size-wise, it's about 3,000 kilograms. For a mass reference on the ground, that's the size of a rhinoceros. So it's a pretty big satellite. The satellite is going to be up there for 15 years in a nominal mission duration. That's quite a long time. So in order to stay up there, it has 2 solar wings that it extends out with 4 panels on each side so that it can remain power positive through the course of years and years and years. It also has reaction wheels to stabilize itself around 3 separate axes. So it is a tried and true satellite design, and it will be going up to geostationary transfer orbits after a quick stint on the Falcon 9.
Now, the Thaicom 8 satellite is currently on top of the Falcon 9. You just can't see it because it's encapsulated by the fairing. Now, the fairing is this nose cone-shaped structure on top of the rocket. We use the fairing to protect the payload or anything else we're launching into space from the intense aerodynamic forces of a launch. Now, unlike the Dragon capsule, which is designed to re-enter through the intense heating of Earth's atmosphere when it comes back from orbit, most satellites going to low Earth orbit or geostationary orbit are a little light. They're kind of not built to withstand those really high, intense air forces. So what we do is we encapsulate inside the fairing. You've actually felt these air forces if you've ever held your hand outside of a car window at highway speed. You can kind of feel the wind pushing your hand around. Well, that's just at highway speeds. You can imagine that the forces would be a whole other order of magnitude once you got up to twice the speed of a bullet, which is exactly the speed that the Falcon 9 attains on ascent. So the fairing itself is huge. It looks kind of tiny on the screen right here, but it's pretty big. It's about 40 feet high and up to 17 feet in diameter. That's pretty much the size of a city bus we could launch if we wanted to inside this thing. It's made of two halves that clamp together with pneumatic pushers, and it's made of a blend of honeycombed aluminum and carbon fiber. So it's actually as low weight as possible, but as high strength as we can get it, which is super important when you're launching stuff to space. So once the first and second stage do their job and bring the payload out of the atmosphere where those intense aerodynamic forces matter, we pop the fairing off using those pneumatic pushers. You can actually see that this is a video from one of our previous launches. You can see those two objects falling away from the second stage. Those are the two halves of the fairing that we're deploying once we're done using them. And you'll actually be able to see this later on when we launch the Thaicom 8 satellite once we get up on top of the atmosphere. So now, once we've popped them off, they typically re-entered the atmosphere, but wouldn't it be really cool if we could reuse them? We're already reusing the first stage, so currently SpaceX engineers are looking into ways to recover the fairing once it pops off. You can actually see some live shot from a previous launch of what it looks like when the fairing pops off. That's the inside of the fairing right there. So just another step towards rapid and reusable launch technologies here at SpaceX is what we're all about. Hopefully we'll be able to see a fairing recovery and a launch coming up pretty soon.
We are just 10 minutes inside the 10-minute mark on the vehicle right now, which means we've begun starting the engine chill of our Falcon 9 rockets. That's the process where we start flowing the cold liquid oxygen into the Merlin engines at the base of the rocket. It's also the point where if you look at the rocket on the screen, you'll start to see that white cloud that Tom mentioned earlier starting to flow and intensify at the base of the rocket. Now, the good news at this moment in time is that we are still proceeding with a nominal LOX and helium load on the vehicles. We're going to continue to load those liquid oxygen tanks, as I mentioned earlier, up until the very final moments. We're also tracking the liquid oxygen temperatures within our second stage and first stage. We have enough margin as well on the temperatures for our liquid oxygen to make sure we have substantial margin for today's flight. Now, the team did begin propellant loading at the T-minus 35-minute mark, which was kicked off with a poll by the launch conductor about 3 minutes prior to that. Everyone gave the go during that launch conductor poll, and we had no issues to report. And we are continuing to proceed into the LOX loading phase at this moment, and nothing should be delaying our liftoff point in 8 minutes from now. Thaicom 8 continues to also be green for today's mission. No issues there to report as well. Meanwhile, the range and weather are going to hold out. We don't need to worry about anything and any constraints to hold us off as well. We are positioning our recovery drone ship about 680 kilometers off the coast of Florida. That drone ship is in a good state as well. We have enough margins for our attempt at landing back on Of Course I Still Love You. So coming up, we have at the T-minus 1 minute mark, our flight computers are entering into startup mode. That's where we begin a final series of autonomous checks, leading into the T-minus 3 second mark, where you're going to see a bright green flash from the base of the rocket, where our T-TEB is going to start as the igniter for our Merlin engines. We'll reach full thrust, the T-minus 1 second mark, and then lift off shortly thereafter. So hopefully all these events pan out, and we are go right now from Hawthorne and Cape Canaveral, Florida.
My name is Lauren Lyons. I'm a mission integration engineer here at SpaceX, and I'm standing here in Tankland in our factory in Hawthorne, California. Now, it's pretty loud in here, and that's because we're making rockets. If you've been following us on social media, you've probably seen that image of the 3 first stages lined up in our hangar at 39A, Cape Canaveral, Florida. The first was flown back to land back in December for our ORBCOMM mission, the first time we ever stuck the landing of a first stage. The second was from our CRS-8 mission, where we landed the stage on our autonomous spaceport drone ship, Of Course I Still Love You, off the coast of Florida, first sea landing. The third is from the JCSat-14 mission, which was just a few weeks ago, where we landed that rocket again. So the next obvious question is, what are we going to do with all those rockets? Well, for the ORBCOMM booster that flew back in December, we actually fired it at the Cape within days of it returning back to land. We were able to gather important data, and we're now making plans to have that first stage displayed outside our Hawthorne headquarters. The most recently returned stage from the JC-SAT-14 mission, we're referring to that as our life leader, which is because it underwent the hottest and fastest re-entry profile yet. That's because it was a GTO mission, and in order to get the satellite up to that super high orbit, you have to go really, really fast. And that fast speed leads to increased heating as it's coming down through the atmosphere and coming back to Earth. In fact, that heating is up to 5 times hotter than what was experienced on previous missions. So what are we going to do at rocket number 3 from the CRS mission, our first drone ship landing?
We plan to refly it later this year.
It turns out many of the parts of the Falcon 9 are actually already qualified for reflight, as they were designed with reusability in mind. As we continue to bring home boosters, we will ramp up our flight-proven vehicle program. Think about it like airplanes. Imagine we threw away the airplane after every single flight. Air travel would be so expensive that no one would really be able to fly. Instead, when an airplane completes a flight and sent back into commission and it's reflown. At SpaceX, we plan to apply that same technique to rockets, hopefully lowering the cost of launch by up to 30%. As you just saw, we now have 3 landed stages in our hangar at 39A. Will today be our 4th? Today's mission has a similar re-entry profile as for the JC-SAT-14 mission, in that it will be coming in fast and hot, which makes this landing really challenging. The launch speeds that the Falcon 9 needs to reach GTO, which is where we're taking Thaicom 8 today, are upwards of 8,000 kilometers per hour, which means that the resistance that the rocket will encounter when coming back into the atmosphere will heat it up pretty good. But that resistance isn't enough to stop the vehicle's descent, so we'll have to use that tiny amount of propellant we have left in the tank to relight the Merlin engines and to slow us down from 5,800 kilometers per hour down to 0 as we gently place the Falcon 9 upright on the deck of the drone ship. But again, while we did stick that last GTO landing, of course, there is no guarantee that we'll have a repeat performance today, but we're still going to try. So the drone ship, of course, I Still Love You, is positioned 400 miles off the coast of Florida, ready and waiting to bring Falcon 9 home today. So enough about the rocket's return journey for now. We still got to launch it, right? So let's pause here and listen on to terminal count.
Strong back motion.
FTS is on internal power. FTS is armed.
T-minus 3 minutes. GNC announced stage 2 TVC motion nominal.
Stage 2 TVC motion is nominal.
Stage 1 locks secured for flight. And in-bag BTV motions.
Strong back retracted and locked out.
Stage 2 lock secured for flight.
T-minus 2 minutes.
Falcon 9's on internal power. Vehicles in self-align. Stage 1, Stage 2, cryo healing, go for flight.
TVC verify Falcon 9 is in startup.
Falcon 9 is in startup. Stage 2, rest up for flight.
T-minus 30. T-minus 20.
Falcon 9, secure to flight pressures.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Liftoff of the Falcon 9. Falcon 9 has cleared the towers. TVC moved to section 10.59 to secure the pad.
Stage 1 propulsion is nominal.
Vehicle pitching downrange.
Falcon 9 power and telemetry nominal.
And Falcon 9 is on its way to delivering the Thaicom 8 satellite to a geostationary transfer orbit. Coming up in about 15 seconds here, we're going to be entering through max Q. It's maximum aerodynamic pressure. It's one of the highest stress states on the vehicle. That vehicle is over 200 feet tall. Just passed through max Q.
Stage 1 propulsion is still nominal.
Entire rocket plus satellite is over 1.2 million pounds. All 9 of those engines capable of putting out 1.71 million pounds of thrust. Put all into comparison, a 26-story building weighs over 300 cars. Now, coming up in about 30 seconds, we're going to have main engine
Recovery vessel has AOS.
AOS being acquisition of signal. That means that the recovery drone ships have reached communication contact with our rocket. In 20 seconds, we're going to have main engine cutoff, or MECO. Followed 3 seconds after that by stage separation, which is done by 4 pneumatic actuators. 3 on the perimeter of the inner stage and 1 in the center. And then after that, we're going to have second stage engine start. You just heard about the second stage engine itself is chilling down. And get ready for ignition. And we have main engine cutoff.
Stage separation.
Stage separation looks good. And it looks like we have a good ignition of a second stage engine.
Stage 1 is entered its flip.
Now you just saw a few events in rapid succession. We had main engine cutoff, or MECO, stage separation, and then second engine start. These exciting homeworks transition the responsibility from the first stage to the second stage of Falcon 9.
As you just said, as you just saw on your screen, the first stage completed all of its fuel autonomy, and so we didn't need that extra mass and tank it, so we separate the 2 stages, let it fall away, and then the second stage takes over and blasts the payload the rest of the way to orbit.
Separation is coming up. Does it just happen?
I think
happened. Just happened.
Oh, that's great. Now, the thing about fairing separation is, upon ascent, you need to protect the spacecraft from aerodynamic heating and from dynamic pressures. But once you're up in the vacuum of space, you actually don't need it anymore. And it's also extra mass. So we deploy the fairing and dump it, essentially.
Exactly, and once we get rid of the fairing, then again, the second stage is the one in charge. First stage got us up outside of the atmosphere and a little bit sideways. Second stage is going to burn much longer, for about 6 minutes or so now, to give us that massive sideways speed boost.
And remember, going to orbit is really not so much about going straight up, it's about going sideways as fast as possible. We need to get that payload to as much delta V as possible, as much speed in this horizontal direction, so it can get into orbit around the Earth. That's what orbit's all about.
And as Brian said earlier today, at geostationary orbit, the speed of the satellite is actually, or the angular velocity of the satellite is actually the same as the rotation of the Earth, so that the satellite is always positioned at the same point in the sky as it orbits the planet.
Yeah, and that's fantastic for communication satellites. You want to be over the same regions that you'll be covering, and so a geostationary orbit and a geostationary transfer orbit that we're going to use to get there is perfect for a communication satellite.
And so we're not out of the woods yet. There's still a few more stages that we need to go through. The second stage is going to burn for about 6 minutes, which we're currently doing right now. Then there's going to be a coast period, and then a second relight after we come back. So we're a lot of great stuff coming up for you.
So why don't we just take it back up and get another status update?
So as you can see right now, so far the mission is proceeding nominally, as we like to say around here at SpaceX. That second stage is looking
Stage
good.
2 propulsion
We
still
have
nominal.
good propulsion, engine temperatures are looking good over here, TVC motion as well as predicted, and power numbers are also looking as we'd expect on the second stage, as it's trying to achieve a parking orbit of about 160 kilometers by 485 kilometers away from the surface of the Earth. That second stage will then coast for about 20 minutes before we're going to do a second ignition to put it into its final geostationary transfer orbit before we deploy the Thaicom 8 satellite. Now coming up, the first stage itself in about 20 seconds here is going to be igniting for its entry burn. That's going to start to slow the vehicle down before we hit the atmosphere. It reached its apogee about 2 minutes ago, over 100 kilometers. You're actually seeing there that view of the second stage falling back to the Earth. Those white puffs are our attitude control systems powering off some cold nitrogen gas, as well as those grid fins are angled outwards to guide you in. And you just heard the entry burn has started. This entry burn will last for about 20 seconds. We're going to be guiding it through the entire way back to, of course, I Still Love You, the drone ship. It should shut off in about 10 seconds or so. Everything here is looking good. Nominal temperatures and engine pressures as well.
Stage 1, entry burn shutdown.
And now we will be keeping that vehicle aligned as we head ourselves back to the drone ship, leading up to a landing burn in about a minute and a half from now, with the goal of touching down at 8:34. Now, this is normal to see the cloudiness in the lens. They're coming back to the atmosphere. Those cameras themselves will be obfuscated and then cleared as we come through the atmosphere. So we'll be showing you as many views as we can. But the good news right now here in Hawthorne, and certainly in space right now, is both first stage and second stage are continuing to proceed nominally on track. So let's check back in with the trio while I keep my eye on the data up here.
So as you just heard from JFED, the re-entry burn of the first stage is complete. That's when the first stage slows itself down just as it hits the top of the atmosphere, so it doesn't damage its engines with the intense heat of re-entry.
Exactly, and once the re-entry burn is complete, we then deploy those
Stage 1 is transonic.
and use the attitude control thrusters, the little white sluts that you saw on the side of the vehicle, to effectively fly back to our final destination of the drone ship.
And as we begin to descend upon the surface of the drone ship, what will happen is those landing legs that are folded up onto the side of the rocket will deploy, and that protects the 9 Merlin engines that are on the bottom of the Falcon 9 as the Falcon 9 lands onto the drone ship.
Now we do have AOS on the drone ship. You can see it on your screen right there. It is possible we might cut out for a second. The vibration of the engines can sometimes shake the satellite link a little bit, but we hope to give you full video through. You'll be able to see the landing burn of the first stage just on the top of your screen.
Stage 1 landing burn started.
Exactly. You can see it on your screen there. What first stage actually does is it runs one engine, then 3, then 1 to slow it down to the final moment. And that's what you're about to see enter frame here.
And
there it is. You're seeing what we're seeing.
Falcon 9 has landed. Landing operator briefing procedure 11.100 and recovery.
Pick it up after this.
stage, landed the first stage on the drone ship successfully, and the primary mission, which is the second stage launch of the Thaicom 8 satellite, is currently going well as well.
So that was an incredible shot right there. You saw the video cut out for about 2 seconds, and then suddenly the first stage was standing right there. That's incredible. Everyone here is obviously very excited. So we have the primary mission is going very well. We have a good orbit, like you were saying. There's a few more steps coming up here. We're about to go to our coast phase, and then we'll come back for a final burn.
Exactly. So we're going to leave you with an animation here for the next 18 minutes. That animation will show you the position of second stage as it continues to deliver Thaicom 8 to orbit. So with a successful landing underneath us and this 18-minute coast phase ahead of us, we're going to take a break for a minute and we'll see you in 18.
Thanks for sticking with us. We are just over 25 minutes into this count, actually just about 26 minutes right now for today's mission. Second stage ignition will restart in about a minute from now. If you were just joining us, we are in a good orbit, a good parking orbit for our second stage. That orbit is about 160 kilometers by 485 kilometers. Second stage did its job splendidly of trying to target that orbit. And as of this moment, we are just standing by for the second stage ignition. As of right now, the second stage has begun chilling in about a minute ago. That chill has proceeded nominally, and propellants and liquid oxygen in the second stage are at a nominal fill rate for what we'd expect for this second burn. This second burn will last for just under a minute and a half. And at that point in time, we will be deploying the Thaicom 8 satellite about 4 minutes after that. We're going to continue to show you this animation as we proceed. That's actually a view from the aft end of the second stage right there. You're looking at the engine nozzle. And the vehicle has entered into its startup mode, getting ready for ignition in about 3 seconds from now. And we are up on power on the second stage. Everything is looking good at this moment. Our pressures are looking good. This burn will last for a minute, as I said. And we are now throttling the engine. The second stage engine is capable of throttling from about 80,000 pound force to 210,000 pound force. We do control that second stage trajectory, as I mentioned earlier, by gimbaling the engine. We are continuing to throttle. I'm listening to the various nets as they're trying to target the final geostationary orbit for the Thaicom 8 satellite. We will be deploying the Thaicom 8 satellite at T plus 32 minutes. So this burn will shut off in about 20 seconds from now. And after that engine has shut off, we will... After that burn has shut off, we will allow the spacecraft to stabilize for a second, and then we will deploy the Thaicom 8 satellite. That Thaicom 8 satellite will perform its final maneuvering to get itself into the geostationary orbit. Everything still continues to look good, and we have shutdown of the second stage engine. And it looks like we are in a good orbit as we planned to target for today's Thaicom satellite.
So now that we just confirmed successful shutdown of the second stage engine, we are now transitioning from the launch phase to the mission phase.
And we actually have a few more steps to go here. The Thaicom 8 satellite is still attached to the top of the second stage by a clamp. And when we're ready to deploy the satellite, we'll release that clamp, and some small springs will gently push the Thaicom 8 satellite away from the second stage so it can do its own thing, send its solar rays, get healthy and everything.
Exactly. And we wait a few seconds before we perform that health contact from the ground. Just got confirmation that we are in nominal orbit still. But we wait about 15 minutes to give a certain proximity distance between stage 2 and Thaicom 8 itself. Once that distance has been established, Thaicom fires up and we do a ground health check to make sure that all subsystems are working nominally.
And after the satellite has separated and it's completed its first health checks and additional health checks later on, what it will do is use its own onboard thrusters to propel itself up to its final orbit, which will be at about 35,000 kilometers above the Earth.
Now, satellites that are going to geostationary orbit like Thaicom 8 have to stay up there for as long as 15 years or more. So they're loaded with a suite of sensors that allow them to function for a long time without any maintenance from the ground. These include suites of sensors like star trackers, sun sensors, Earth horizon sensors that allow them to position themselves in precisely the right direction so they can serve the intended markets on the ground with their antennas.
Exactly, and those fantastic sensor suites consume a bit of power. Well, how does it stay alive for the 15-year-long mission that it intends to? That's with the solar array. So as I mentioned earlier, there's one wing on each side, and each of those has 4 panels. That allows us to effectively plug a wireless charger into the sun, harvest that energy, and stay power positive throughout the 15 years it's supposed to.
And on this 15 years, It turns out we actually can't service these satellites. They're really, really high up, and we don't have any programs right now to be able to get up there and fix them should something go down. So it's critical that the satellite be able to power itself, and that it does these health checks, and that it can actually survive the 15 years of its planned life.
And it is really high up there. 35,000 kilometers, like we were saying earlier, is so high up that the orbital rotation matches the Earth's rotation. So from the perspective of someone on the ground, it looks like a star in the sky. That means you can point your dishes at it. There's actually an animation right here that shows exactly where it's going. That was our first second stage burn. You can see the first stage landing, fairing deploy, and then what just happened a few seconds ago was the second stage second burn. That just happens right there. And then the final payload deploy, the Thaicom 8 satellite, is coming up in just a few minutes here, so it can achieve its final 35,000 kilometer geostationary orbit.
Yeah, and 35,000 is worth reiterating. For reference frame, the International Space Station, where our Dragon capsule goes to resupply the astronauts, that sits in low Earth orbit, or LEO, which is about 350 kilometers. This is going to nearly 36,000 kilometers. It's pretty high up.
And so to recap how we got to this point, we had a great launch of the Falcon 9 rocket. We landed the first stage. The second stage then continued on its journey. We're now in a really good orbit, and we're just counting down until we deploy the spacecraft.
So what you're about to see is a forward-facing camera view from the top of the second stage. You'll be able to see the Thaicom 8 satellite, and hopefully, if everything goes well, we'll see that satellite gently push away, floating off in the zero gravity of orbit, so that it can do its own health checks and deploy its own solar panels. That should be coming up in just a few seconds here. And it sounds like, oh, there it is. You can see the Thaicom 8 satellite gliding away.
So that is Thaicom 8 separated from SpaceX's second stage to do its multi-month mission to geostationary orbit. With excitement and fantastic preparation behind us, we now turn to the next few months as Thaicom continues to reach its final destination.
This actually ends our portion of the launch today and our portions of the mission, because the satellite is no longer actually attached to the Falcon 9. So to wrap up today, we would like to thank our customer, Thaicom. We would like to thank the range for the range support, and we would like to thank all of you.
And since this is the United States, the weekend of Memorial Day, we'd like to express our deepest gratitude and appreciation for all those who have given their lives in service of our country.
I would like to thank you, the viewers, thank our customer, thank the Air Force and the range. Make sure to follow us on social media, and just remember, wherever your travels may take you on Memorial Day, whether it even be to geostationary orbit, don't forget to bring a towel.